Okay. Actually, it was a supply interruption at my side, right? I think some of the participants have rejoined. Okay. So, am I audible to all? Right? Okay. 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 Good. So, right. Right. Okay. So, we were at the discussion of mode 3, right? Mode 3. So during the mode 3, we discussed at the start of the mode 3, the gate pulse is applied to the auxiliary thyristor. So as soon as auxiliary thyristor turns on, capacitor will try to discharge through this loop, and due to that, suddenly reverse voltage will appear across the main thyristor, and suddenly very high reverse current will be flowing in opposition to that of the load current, okay, through the thyristor T1. So that's why the thyristor T1 will turn off immediately, right? So next, after that, the capacitor will discharges through C, auxiliary thyristor, load, and again back to the VS in this loop. So when capacitor discharges through this loop, it is like IC is equal to minus I0. Okay. So now what will happen if IC is equal to minus I0? So it is like a capacitor current is a negative and it is a constant current, right? Because we are having a load current is a constant. Na? So if the load current is constant, so therefore your IC is also constant. IC is also constant. So now what will happen during this mode? You can check the waveform of IC. Waveform of IC. So here we are having the IC. It is equal to minus I0. Magnitude is I0, right? Magnitude is I0, but it is a negative, no? So that's why it is a minus I0. Now during mode 3, what will happen? Here IC is constant. If IC is constant, what about the VC? You can check. VC means what? It is a 1 by C integration of IC dt. Na? So let me write here. VC is equal to 1 by C integration of IC into dt. Okay. So capacitor is discharging. But this IC is constant current. But this IC is a constant current, right? It is a constant, which is equal to load current. Why the IC is constant? Because capacitor is discharging through the load, na? So as capacitor discharges through the load, and load is highly inductive, so that's why definitely load current, yes, should be constant only. So that's why your IC will be constant. As IC is constant, what about the integration of that constant term? Integration of constant term is like your ramp signal. Are you getting the point? Integration of constant is a T, na? Integration of constant is equal to T. So that's why it is a ramp signal. So you can check during the mode 3. What is happening actually? This capacitor will discharges and again charges to the reverse polarity. Capacitor will discharges and again charges to the reverse polarity. So when capacitor will discharge, so at that time the polarity will be plus here, minus here. The voltage across capacitor is Vs only. When capacitor discharges and charges to the reverse polarity, so at the end of mode 3, if you check at the end of mode 3, the voltage across capacitor will be like plus here, minus here, and again this voltage, yes, will be equal to Vs only. Please check the waveform of Vc, you will understand. So you can check the waveform of Vc. So here IC is a constant current. IT1 is 0 because thyristor T1 has turned off. Na? Thyristor T1 has turned off, so IC is equal to 0. Capacitor is discharging through the load. Na? So that's why load current is a constant, right? Current is flowing through the load. So load current is a constant only. Next, so load current constant, IT1 0, IC is minus I0. As IC is a constant current, what about the VC? Vc is a 1 by c integration of Ic dt. Ic is constant, so integration of that constant term is a ramp signal, right? That is a t. T is nothing but ramp signal. In the signal system, you might have seen where having the impulse signal, step, ramp signal, parabolic signal, etc. Okay, so T indicates what? It is a ramp signal. So that's why here we can check as this is constant. So that's why here our voltage across capacitor is a changing linearly. If you check mode 1, in the mode 1, capacitor current was sinusoidal, capacitor voltage was co-sinusoidal. In the mode 3, capacitor current is constant, capacitor voltage is a linear. Capacitor is discharging from this minus Vs, it will discharge fully and again charges to the reverse polarity. So at the end of mode 3, if you check at the end of mode 3, it is like capacitor has discharged fully and charged to the reverse polarity. Reverse polarity charged means what? The upper plate of the capacitor will be positive, lower plate of the capacitor will be negative. But what is the voltage across the capacitor? It is a Vs only. Okay, so voltage across capacitor is Vs. So that's, it is like capacitor discharges through auxiliary thyristor like this and again charges to the reverse polarity. So that's why it is plus here, minus here. So this is a Vs now. Okay, so that's why this is a capacitor voltage waveform. Next, what about the Vt1 waveform? You can check Vt1 waveform. Here Vt1 means this waveform. Vt1 is this waveform, right? So you can check, can we say that for the capacitor voltage, whatever we are having, this Vt1 voltage across capacitor will appear as a reverse voltage now for thyristor T1. You can check capacitor voltage is like minus here, plus here, this is Vc. So minus of the capacitor is appearing at the plus positive terminal of the SCR, that is the anode, and plus is appearing at the negative terminal of the SCR. Okay, so that's why Vt1 is like your minus Vs. Vt1 is like your minus Vs. Is this clear? But your Vc is already negative, na? Vt1 is equal to minus Vc. Vt1 is equal to minus Vc. Either you can apply KVL to this loop, you will understand. You can apply KVL to this loop. If I apply KVL to this loop, it is like a minus Vc minus Vt1 is equal to 0. So therefore, what is Vt1? Vt1 is equal to minus Vc. Vt1 is equal to minus Vc, right? So the voltage is, capacitor voltage is negative actually. Okay, but we have reversed the polarity, na, minus here, plus here, like this we have indicated. Okay, so that's why voltage across thyristor T1 is also negative. You can check here. So voltage across capacitor here and voltage across thyristor T1, right? Both are same. Both are same. Is this clear? I am saying same. Why? Because we have, please don't get confused, because capacitor voltage here negative, and for that negative voltage we have considered polarity, right? This is minus and this is plus, na, right? So whatever the voltage here with this minus, this plus, it is like your plus voltage only, positive voltage for the capacitor. So that's why your Vt1 will be same as that of your capacitor voltage. Okay, same as that of your capacitor voltage. Now next, so what about the V0 now? V0, you can check V0. Here it is a V0 we are having. So check here, when capacitor discharges, okay, when capacitor discharges, it is like a voltage across load is equal to Vs, this Vs plus voltage across capacitor. Vs plus voltage across capacitor is nothing but your V0. So you can check, as soon as thyristor Ta turns on, as soon as thyristor Ta turns on, voltage across load is equal to this voltage Vs, and here minus, here it is plus, this voltage was Vs, na? So it is like Vs plus Vs, 2 Vs voltage will appear across the load suddenly. As soon as thyristor Ta turns on, at that instant V0 is equal to 2 Vs. After that, what will happen? This Vs decreases, na, because capacitor is discharging. Capacitor discharging means indirectly this Vc is discharging. So as Vc discharges, what about the V0? V0 is Vs plus Vc, na? So Vs plus Vc will be like, yes, Vs will be there. Okay, constant voltage Vs is there, but Vc is your discharging. So as Vc is discharging, so what about the Vs plus Vc? That will be changing from 2 Vs to, it will be decreasing. Okay, so you can check the V0 waveform here. You can check the V0 waveform. It is like, as soon as auxiliary thyristor turns on, this at this instant auxiliary thyristor turns on, voltage across load is equal to 2 Vs. You can check, this voltage is 2 Vs. This point is 2 Vs. Okay, so next, if this is 2 Vs, after that capacitor, as capacitor discharges, na, so here voltage across the load go on decreasing. Next, when capacitor discharges and charges to the reverse polarity, so you can check, when capacitor discharges fully and charges to the reverse polarity means plus here and minus here. when capacitor discharges and charges to the reverse polarity. What is the V0? V0 is equal to Vs and this minus Vs na, because you can check equal and opposite forces. This is also Vs. This is also Vs. This Vs will try to circulate current in the clockwise direction. This capacitor, which is charged to the voltage of plus here minus here, this will try to discharge the current in the anti-clockwise direction, try to circulate the current in the anti-clockwise direction. So it is like V0 is equal to Vs and this Vs, both will be equal and opposite. So V0 will be reaching the zero voltage. You can check the V0 waveform. V0 waveform here you can check. It is a zero voltage na. So that's why when capacitor S reaches to the Vs volt, plus Vs means what? It is like a capacitor upper plate positive, lower plate negative, and the magnitude is Vs. And this minus Vs means what? It is like a capacitor lower plate positive, upper plate negative, and the magnitude is Vs only. Okay. So that's why here V0 is equal to 0 volt. V0 is equal to 0 volt, right? Now, so you can check here, if at this instant, capacitor has charged, at this instant, the capacitor has charged to the voltage of plus here, minus here. Okay. And this voltage is Vs now. Okay. Upper plate positive, lower plate negative, and this voltage is Vs now. So now you can check here, once capacitor charges to the plus here, minus here, upper plate positive, lower plate negative, this capacitor will try to circulate current in this direction. That is, capacitor will try to discharge. Okay. But equal and opposite forces, capacitor will not discharge. This capacitor will try to discharge to the main thyristor, but main thyristor, whether it is in on state, no. So capacitor will not discharge. So as the discharging path is not available for the capacitor, so you can check during the mode 4, capacitor will hold the same voltage. Capacitor will hold the same voltage, that is the Vs. So during mode 4, what is the Vs? Vc is equal to Vs only, because discharging path is not available. So if Vc is equal to Vs, what about the Vt1 here? That is the voltage across thyristor T1. Voltage across thyristor T1 is equal to, yes, this is Vs, okay, minus this voltage across the load. Now point to be noted here, what will the voltage across the load during the mode 4? During the mode 4, what is happening? Capacitor, for the capacitor, discharging path is not available. So that's why already T1 is in an off state. Okay. Your TA, important thing regarding the what about the auxiliary thyristor TA? You can check if the capacitor current becomes equal to 0 at this instant. At this instant, when capacitor charges to the polarity plus here, minus here, so capacitor discharging path is not available. So that's why IC becomes equal to 0. If IC is 0, what about the TA? TA also equal to 0. So thyristor TA current becomes equal to 0. So thyristor TA current is 0 means what? Your thyristor TA will turn off na, because anode current is less than the holding current value. So that's why thyristor TA will turn off. So thyristor TA is also off state. T1 is also in the off state. So now what will happen? This load inductor will release the energy through the freewheeling diode. Right? In order to maintain the constant current through the load, this load inductor will release the energy through the freewheeling diode. So you can check during mode 4, T1 is off, TA is also in the off state. This load inductor is releasing the energy through the freewheeling diode. So that's why your I0 will be maintained a constant only, that is a capital I0. So during the mode 4, I0 will be constant, that is a capital I0 only. Right? What about the IT1? Thyristor T1 is off state, so IT1 will be 0. What about the IC? IC is also 0 now, because for capacitor discharging path is not available. So IC is equal to 0. So here IC is 0. IT1 is 0, right? Next, I0 is I0. Capacitor is holding the same voltage now, because discharging path is not available. And what about the VT1? VT1 is, now you can check, or let me draw first during the mode 4, the equivalent circuit. Mode 4. Equivalent circuit, right? Mode 4 equivalent circuit. Now in the mode 4, what is happening? We're having supply voltage here. This is a Vs. Thyristor T1 off state. Capacitor voltage upper plate positive, lower plate negative, no? Plus minus, this is a Vs, which is equal to Vc, right? Auxiliary thyristor off state, right? Auxiliary thyristor is in an off state. Diode D off state. Inductor here. Right? So this type of circuit we are having. And here freewheeling diode is in a conduction mode. Load inductor releases the energy through the freewheeling diode in order to maintain the same current through the load. R, L and E, right? This is a I0, which is equal to I0. Here load inductor is releasing the energy. This is your freewheeling diode. FD, right? Next, IC is this current. Okay, this is a VT1. VT1. Okay, now you can check here in this circuit. This is a L diode D and this is a TA. In this circuit, capacitor is not discharging, so IC is equal to 0. IC is equal to 0 ampere, right? What about IT1? IT1 is equal to 0 ampere because thyristor T1 is in off state, na? Right? Already it has turned off, na? Right? So IT1 is 0 only. Next, load current is constant. Load inductor releases the energy through the freewheeling diode. Let me write load inductor releases energy through freewheeling diode. Right? Freewheeling diode. Okay. So that's why your I0 is constant. What about the V0 in this case? You can check V0. V0 means this voltage, na? Let me write here. This is a V0. Voltage across load is nothing but voltage across your conducting diode, na? Because inductor is releasing the energy through the freewheeling diode. So what is the V0? That is voltage across load is equal to voltage across this branch. What is the voltage across this branch? Diode is in on state, na? So what is the voltage across this diode is equal to 0 volt. Theoretically speaking, 0 volt, right? So here, therefore, voltage across load V0 is equal to 0 volt, right? V0 is equal to 0 volt. Now we are having V0 0 volt, VT1 here and here it is Vs. You can apply KVL to this loop now. You can apply KVL to the outer loop. You will get plus Vs minus VT1 minus V0 is equal to 0. Let me write KVL to outer loop. KVL to outer loop. Yes, we'll be getting plus Vs minus VT1 minus V0 is equal to 0. But what is V0? Just now I written V0 is equal to 0, right? V0 is 0. So therefore VT1 is equal to Vs. Voltage across the main thyristor is Vs, right? Voltage across main thyristor is Vs. So you can check here the waveform. Yes, VT1 waveform. It is a Vs only mode 4. Okay. After that, V0, we are having 0 volt. V0 0, VT1 is Vs. Vc is capacitor is not discharging, no? So Vc is equal to Vs. IC is 0. Discharging path is not available. So capacitor is not discharging. So that's why it is a 0 ampere only. IT1 is 0, right? IT1 is 0, right? IC is 0, IT1 is 0. I0 is constant current. Okay. So this is still mode 4. After mode 4, what is happening? Again, the same repeats. Again, the same, because you can check after the mode 4. Again, we applied the gate pulse to the main thyristor. So same cycle repeats actually. Same cycle repeats. Is this clear? So this is the circuit operation. This is the circuit operation of the voltage commutation. Okay, voltage commutation technique. Why the SR is turning off? Due to the high reverse voltage. Due to the high reverse voltage maintained across the SCR. Right? Due to the high reverse voltage maintained across SCR. Now, let me again repeat it. Please concentrate. I am repeating the operation. Let me erase it first all. Yes. So initially, yes, for t less than 0, initially for t less than 0, yes, it is like a circuit was at the rest position. The only thing is switch was in a on state. When switch yes was in on state, it was like current was flowing through this loop, na? Current was flowing through this loop. So capacitor was charging. As time approaches 0 minus, capacitor voltage reaches the Vs volt, na? So capacitor voltage will be equal to Vs volt for t less than 0 only, right? Next, at t is equal to 0, at t is equal to 0, what is happening? At t is equal to 0, where applying the gate signal to the thyristor T1. So here thyristor T1 turns on. Thyristor T1 turns on. Okay. Next, we are turning off this main switch. Yes, we are turning off the main switch. Yes. Okay. So when T1 turns on, it is like capacitor go on discharging through the T1, inductor, diode, and again back to the C. In this loop, capacitor discharges and again charges to the reverse polarity. This is the one active loop. Second loop, one current is flowing from Vs, thyristor T1, load, and again back to the Vs. So your thyristor T1 current, that is a IT1 current, is equal to addition of load current and your capacitor discharging current. Okay, so IC plus I0 is nothing but your IT1. But I0 is a constant because we consider the load is highly inductive. No? Load is highly inductive. So here you can check at t is equal to 0, thyristor T1 turns on. After that, I0 is equal to constant current during mode 1. Next, IT1 is equal to addition of load current and IC. Na? IC we derived the expression and IC is equal to sinusoidal we got an expression. Okay, so this is the expression waveform for the IC. IC plus I0 is nothing but your IT1 is nothing but your IT1. Is this clear? Next, this will continue till mode 1. During the mode 1, what is happening? Capacitor is discharging and again charging to the reverse polarity. So capacitor discharges and again charges to the reverse polarity. So here voltage is changing from plus Vs to the minus Vs. This minus Vs is how we are representing this minus Vs, like a plus here and minus here. This is equal to your minus Vs. This polarity is only reversed, right? Lower plate negative positive, upper plate negative. Lower plate positive, upper plate negative means it is like a minus Vs. Okay. So next, what about the VT1? VT1 is 0 because thyristor T1 is in on state. Okay, and what about the V0? V0 is equal to Vs only. Na? So V0 is equal to Vs. This is during mode 1. During mode 2, what happens? Yes, once capacitor discharges and charges to the reverse polarity. So capacitor now will be having the polarity like lower plate positive, upper plate negative. So this capacitor is not having any discharging path. Okay, because auxiliary thyristor yet were not turned on. And next, this diode D also will feel the reverse voltage. Due to that, our diode D will be in the off state. So capacitor will not be discharging. So if the capacitor is not discharging, so what about the VC? VC will remain constant. That is the minus Vs. You can check VC is equal to minus Vs. What about the IC? Capacitor is not discharging. So IC will be 0 now because current is not flowing in this loop. In the capacitor branch, current is not flowing. So IC is equal to 0 only. IC 0, VC is minus Vs. Now only one loop will be active, that is the outer loop. Na? Outer loop will be in the active state. So that's why load current will be flowing from Vs, thyristor T1 load. And load current is a constant because load is highly inductive, right? So that's why your thyristor T1 current is only I0. So you can check during mode 2, thyristor T1 current is only I0. What is I0? I0 is again same as that of the constant current I0, right? Because load is highly inductive. So load current is equal to capital I0. So it is a capital I0. This is also I0. IC is 0 because capacitor is not discharging. VC is equal to minus Vs. VT1 is 0. Thyristor T1 is in on state. Na? So VT1 is equal to 0 and V0 is equal to Vs only. This will continue for mode 2. Next, so at the end of mode 2, what is the status? It is like a capacitor has charged with a polarity of lower plate positive, upper plate negative. Next, at the start of mode 3, we are going to apply the gate pulse to auxiliary thyristor. Once the auxiliary thyristor turns on, our capacitor will try to discharge in this loop, na? In the opposite direction to that of the thyristor T1. So it is like for thyristor T1, very high reverse current will be flowing. And due to that reverse current very high, the thyristor T1's current suddenly becomes to 0. Because initially through the thyristor T1 current was load current. Second current is the discharging current of the capacitor, right? Both will be opposite to each other. But capacitor discharging current value is very high. Okay, because capacitor voltage is Vs volt, na, right? And that very high current will be flowing. So that's why resultant current in the thyristor T1 will suddenly drop to the 0 value. So that's why it is suddenly dropping to the 0 value, right? Next, so once thyristor T1 turns off, now what will happen? Our capacitor will discharge through the load. Okay, capacitor will discharge through the C, TA, load, Vs, and again back to the C. In this loop, the capacitor will discharge. But in this loop, when capacitor discharges, IC is constant now because it is discharging through the load and load current is constant. So that's why your capacitor current will be constant. And that IC is equal to minus I0, right? IC is equal to minus I0. So if IC is constant, your VC will be like a ramp signal, right? So capacitor will discharge and charges to the reverse polarity. So this is IC constant, capacitor voltage will be ramp signal. It is a linear. In the mode 1, it is a sinusoidal IC. VC was co-sinusoidal. In the mode 3, capacitor current is constant. So that's why VC is your linear signal, right? Linear type of VC will be like a ramp or the linear type of nature you will be getting. So it is changing from minus Vs to the plus Vs, discharges and again charges. Similarly, we are having the VT1 waveform, we are having the V0 waveform as well. During the mode 4, what will happen? It is like capacitor again charged to the polarity, like here it is plus, Here it is minus. Okay, mode 4 I am saying. During the mode 4, it is like capacitor has charged to the voltage of upper plate positive, lower plate negative. So capacitor will try to discharge through this loop, but thyristor T1 is in off state, right? So that's why thyristor T1 is in off state. So capacitor will not discharge through the thyristor T1. Capacitor will try to discharge in opposition to the supply voltage, but equal and opposite forces, right? So that's why capacitor will not discharge. As capacitor is not discharging, our main auxiliary thyristor also will turn off. Once auxiliary thyristor turns off, it is like free load inductor go on releasing the energy through the freewheeling diode, right? Through the freewheeling diode. So this is the overall operation of the circuit. Now here we are going to write the expression for the circuit turn off time. Circuit turn off time. So first thing, what is the circuit turn off time expression in this case? How to find the circuit turn off time? If you check, we are having circuit turn off time, it means it is an interval, na? So first of all, we need to check the instant at which current flowing through thyristor T1 becomes 0. Our main thyristor is thyristor T1. Okay, our main thyristor is thyristor T1. Okay, so for thyristor T1, if we want to find the circuit turn off time, first of all, we need to check the instant at which current flowing through thyristor T1 becomes 0. So you can check the instant at which current flowing through thyristor T1 becomes 0 is, this is IT1 we are having. Current flowing through thyristor T1 becomes 0 at this instant, na? At the start of mode 3, current flowing through thyristor T1 becomes 0. After that, check the VC waveform. After that, you can check the VC. This is a VC waveform, na? So at this, from this instant, right, you can check from this instant, the reverse voltage is maintained across the, right? After that, check the, not the VC, check the VT1 waveform, because voltage across the thyristor is required to be negative, na? Right, reverse voltage. So corresponding to this point, the on VT1, it is this point here we're having. Corresponding to this point, we're having on the VT1, here it is the point, na? Here it is a point. So after this point, you can check the reverse voltage is maintained only during this interval, na? Means from this point to this point, from this point to this point, the reverse voltage is maintained. Reverse voltage is maintained across the thyristor T1. After this point, you can check VT1 is positive, na? So VT1 is positive means it is a forward voltage. We are interested in only reverse voltage interval, na? Right? So here reverse voltage is maintained only from this point to this point. So can we say that this indicates from here, right, to here? What is this? This indicates, let me write here. This is a TC, circuit turn off time for thyristor T1. Please check how to find the TC. First point is, we need to identify the point instant at which the current flowing through thyristor T1 becomes 0. Current flowing through thyristor T1 becomes 0, right? How to find that? For that, we need to check the waveform of IT1. IT1 is nothing but the current flowing through T1. Current flowing through T1 becomes 0 at this instant, na? Corresponding to this point, if you check on VT1, right, here it is a VT1 we are having. So from after, once current becomes 0 means it is like our thyristor T1 has turned off. But whether it has successfully turned off or not, it depends on its circuit turn off time. Are you getting the point? It depends on circuit turn off time. Means for how much time interval the reverse voltage is maintained, right? That decides your whether the SCR is successfully turned off or not. Okay, next. So here you can check corresponding to this point on VT1, here we are having the point. So from here till this point, we are having the reverse voltage, na? So this indicates the TC for thyristor T1. Now, how to find the TC value? How to find the TC value? Let us discuss. Now you can check corresponding to TC. Corresponding to TC. What is the IC corresponding to TC? IC is I0. And what is the VC? VC is linear, na? Now you can write, can we write during TC, let me write during TC, yes, capacitor current IC is equal to C into dVC by dt, okay. So during TC, what is IC? Magnitude of IC. During TC, what is the magnitude of IC? It is I0, na? IC is equal to I0, which is equal to C into dVC by dt, na? Because we know in the case of capacitor, current IC is equal to C into dVC by dt. During TC, what is IC? IC is a I0. What is a dVC by dt? dVC means change in the capacitor voltage. dVC means change in the capacitor voltage. You can check during TC how the capacitor voltage is changing. It is changing from minus Vs to the 0, na? TC means this point I am saying from here to here you can check capacitor voltage changing from minus Vs to 0. So what is the change in the voltage? It is a 0 minus of minus Vs. So that is a Vs only. Okay, that is a DVS. DVC actually, DVC. And what about the DT? DT is nothing but change in time. From this point to this point, what is the change in time? That is a TC. So let me write it as, can we write it as, yes, I0 is equal to C into DVC matlab means what? It is a 0 minus of minus Vs. Initial voltage was minus Vs. During TC it has changed to the 0 now. So that's why final value minus initial value. Divided by dt means what? It is a TC. dt means TC. So therefore I can write, therefore TC is equal to, yes, we can write TC is equal to C into Vs divided by I0. C into Vs by I0. This will give you the circuit turn off time for thyristor T1. The circuit turn off time for thyristor. Let me write it as, this is circuit turn off time. Circuit turn off time for thyristor T1. For thyristor T1. Okay, for thyristor T1. Next, what is the peak value of current flowing through thyristor T1? Second one, peak current through thyristor T1. Peak current through thyristor T1. That is nothing but what? IT1 peak. IT1 peak. Yes. What will be the peak value of current flowing through thyristor T1? You can check the IT1 waveform. IT1 waveform, here it is. What is the peak value of current flowing through thyristor T1? It is a I0. This is the peak value now, right? This is the peak value. It is a I0 plus peak value of capacitor. Peak value of capacitor is Vs under root C by L, na? Right? So this is the peak value of capacitor. So Vs under root C by L. And that's why peak value of the thyristor T1 is I0 plus Vs under root C by L, right? So it is a I0 plus IC peak, which can be written as I0 plus Vs into under root C by L. This is your IT1 peak. This is your IT1 peak. Yes. Next, what about the peak value of current flowing through the auxiliary thyristor? Yes, can anyone? What is the peak value of current flowing through the auxiliary thyristor? We have not drawn the waveform of auxiliary thyristor current, but we can draw. Okay, but from the circuit operation, yes, we can find the peak value of current flowing through the auxiliary thyristor. Come on. What will the peak value of current flowing through the auxiliary thyristor? I0. Yes or no? I0. Why? Because capacitor discharge, when auxiliary thyristor turns on, it is like capacitor discharges through the load, na? And when capacitor discharges through the load, how much current is flowing through the auxiliary thyristor? It is a constant current I0, right? So peak value of current flowing through the auxiliary thyristor is equal to I0 only, right? So peak current through auxiliary thyristor, through auxiliary thyristor TA, right? Let me write it as ITA peak. It is equal to I0 only. It is equal to I0 only, right? ITA peak is equal to I0. Is this clear? Right? So peak value of thyristor T1, peak value of auxiliary thyristor current, and circuit turn off time for thyristor T1. Okay. So this is about the class B, voltage commutation. This is about the voltage commutation, right? Next, let us discuss one numerical, and after that we'll stop. Yes. Simple example. For a voltage commutation circuit, Vs is 230 volt, C is equal to 40 microfarad, L is equal to 20 microhenry. Constant load current I0 is given 120 ampere. Calculate peak value of current through the capacitor, through the main thyristor and auxiliary thyristor. Means peak value of capacitor current, peak value of thyristor T1 current, and peak value of auxiliary thyristor current, right? And circuit turn off time for main thyristor. Okay, so 4 things we need to find. First of all, let us note the data. Supply voltage is 230 volt. C is equal to 40 microfarad. L is equal to 20 microhenry. Okay. I0, that is a load current, is equal to 120 ampere. Yes. So first thing, peak current through the capacitor, IC peak. We know it is a Vs under root C by L. Vs into under root C by L. We have written the expression for IC, na? Right? So Vs is 230 into under root C by L. So 40 into 10 to the power minus 6 divided by 20 into 10 to the power minus 6. Right? Vs under root C by L. So you can check it is 230 into under root 2, na? So that will be equal to 325 point something, na? Right? 230 root 2. 225.27. Okay. Next, what about the peak value of current through the main thyristor? IT1 peak. Just now we have written it is a I0 plus IC peak. Na? I0 is 120 and plus IC peak is 325.27. So it will be like a 445.27 ampere. Na? Correct? This is a IT1 peak. Next, ITA peak. ITA peak is equal to I0, na? Which is equal to 120 ampere. Second bit, circuit turn off time. Circuit turn off time for main thyristor. Okay, so TC, which is equal to, I have written the expression C into Vs divided by I0. C is 40 microfarad. 40 into 10 to the power minus 6 into Vs 230 divided by I0 is 120. So if we check, it is equal to 76.67 microsecond. Okay. Is this clear? So stop here. If you are having any doubts, please ask. Yes.
Hello, sir.
Yes, please. You are audible, please.
Sir, can you go for graph, sir, once again? TC.
Just a minute. Let me allow all the students. So, which graph?
Sir, this one, voltage computation graph.
Voltage commutation. Okay, okay, yes.
Sir. Sir, can you show TQ in this graph?
Which one?
TQ, sir, device turn off time.
Okay, TQ we cannot show here.
Sir.
Because TQ is the turn on time. TQ is the device turn off time.
I think
it will be specified by the manufacturer. We cannot show here.
Okay, sir.
Are you getting the point? But the thing is, if the SR T1 is to be successfully commutated, then in that case, we need to select the value of this L and this C such that this TC, whatever we are getting, that should be equal to your TQ.
Okay, sir. Equal to or greater than TQ?
Yeah, equal to or greater than, right?
Yes, sir. Yes, sir. And one more thing, sir.
Yes.
During TC, you made a derivation, sir, in this circuit.
Yes,
in
yes,
this analysis.
yes.
Can you open that, sir?
Okay. Yes, here it is.
Sir. Sir, why we are not taking IC is equal to minus I naught?
You can check now, if IC is negative, then your TC will be negative.
Sir.
It doesn't have any meaning, whether the time will be negative.
Means we should take mod IC?
Oh, yes, yes, we should take mod IC only.
Okay, sir.
Right?
Okay, sir.
Sir.
Hello, sir.
Yes.
Sir, in graph,
Hello?
voltage commutation graph, sir.
Yeah, voltage commutation graph. Okay.
Sir, mode 3.
Mode 3,
Sir, here VT1 voltage across thyristor 1 has been turned off, sir. Then why it is showing a ramp signal, sir. Then how it is increasing, sir? Mode 3.
Okay,
It is turned off,
You can
but
check
why?
na, during mode 3, the VT1 is nothing but your VC.
Oh, okay,
You can apply
okay.
KVL here. Na. During mode 3, what happens? This is in the on state. Na.
Yes, sir.
If this is in a on state, you can apply KVL to this loop.
Oh, okay, sir.
So it is a plus here, minus here. Okay.
Ah,
Right? The VC polarity is like plus here, minus here. We considered for positive VC. Yeah? For positive VC, the polarity is plus here, minus here. Na?
okay, sir.
So
Sir,
this
in
is
mode.
like,
Yes, sir.
no, let me finish first. So
Okay.
when VC positive, we are having polarity plus here, minus here. Definitely, whatever you are saying, ki mode 3, the VC polarity is like lower plate positive, upper plate negative. It is okay. But
Yes, sir.
please listen. VC polarity we are having plus here, minus here. This is for positive value of VS. When VS is positive.
Okay, sir.
Okay. So if we apply KVL to this loop, what we will be getting? It is a plus VC minus VT1 is equal to 0. Na?
Yes, sir.
So if I write plus, yeah, just a minute. Yeah. If I write plus VC minus VT1 is equal to 0. Therefore, what is VT1?
VC.
But what is your actual VC? Whether it is a positive or negative? You can check
Negative.
during mode 3. During mode 3, what is VC? Negative, na? Negative to positivity changing, na?
Yes, sir.
So during mode 3, whatever the VC we are having, that is this waveform. Same waveform will appear for VT1 also, like this.
Okay. Sir, and another doubt, sir.
Yes.
In mode 3, you said IC equal to minus I naught. How minus, sir? Because IC is also flowing through the load only, no, sir. Then how minus will come?
Actually, the thing is, we consider a positive value of a positive direction for IC is upward direction.
Okay, sir.
IC upward means what? It is like a IC positive.
Okay, sir.
But actually during mode 3, what is happening? The current is capacitor actually having the polarity during the mode 3. You can check during the mode 3. We are having circuit. Yes, here it is. Na? During mode 3, this is actually upward direction IC means IC positive. Okay. But
Okay,
during
sir.
mode 3, capacitor is discharging like this. Na? Polarity
Ah.
was plus here, minus here. And so it is discharging like this.
Okay,
So
okay,
in
okay,
this
sir.
capacitor branch, how the capacitor current is flowing downward.
Yes, sir.
So that's why it is negative.
Okay. Okay, sir.
Right?
Sir, yes, sir. Sir, another doubt, sir. Sir, you said inductor will oppose in the changes which is made instantly, sir.
Yes.
In previous commutation circuit also, you showed at t equal to 0, inductor as an open circuit. But here you didn't mention that inductor as open circuit in load. You have considered it as it's working. How, sir? Here, why it's not opposing the immediate change, sir?
No. Actually, here we have considered the operation like a steady state.
Okay,
You are
okay.
saying about the load inductor, na?
Yes, sir.
Yes. We are neglecting that small transient period here in the case of load.
Okay, sir.
So that's why we are getting this constant.
Okay.
But if you check for the very first cycle, if you want the value of expression, if you want the waveform of I0 for the very first cycle, na? Very first cycle means suppose this switch is closed, this switch is open. As soon as T1 is turned on, na, then
Yes,
your
sir.
I0 will be for very first instant, it will be like this.
Okay,
From
sir.
0 it will start. But
Okay.
we can neglect this very small period. So that's why it is fine.
Okay. Thank you, sir.
Okay.
Hello, sir. Good evening.
Hello, sir.
Yes, please.
Sir, in the natural commutation, sir, in every positive cycle, we have to get
Just a minute.
current, sir.
Natural commutation you are saying.
Sir, in any commutation, we have to get a voltage in every positive cycle. Means in the positive cycle itself.
For the natural commutation you are saying.
Sir, in the natural commutation for negative cycle, the thyristor gets off, and for
Thyristor will
positive,
be in the reverse bias mode, huh?
sir. So it gets off now, sir,
Yes, it will be in the off state, huh?
because the for that time it is in the off state, negative cycle. That's why. And for the positive next cycle, the gate should be applied. Otherwise, it should be off.
Yeah. If the SCR is in a forward bias mode. Two things we are having. One is SCR forward bias mode. Second one is SCR reverse bias mode. When supply voltage is positive, I am saying for natural computation, when supply voltage is AC, right? So that is during the positive values of the supply voltage means 0 to pi, your SCR will be in the forward bias mode.
Yeah,
So
sir.
if SCR is in a forward bias mode and if you apply the gate signal, then and only then your SCR will turn on.
Sir, and that's why I'm asking, sir, in every positive cycle, we have to give gate signal.
Yes. Every positive cycle we have to give the gate signal. It is not
Sir,
like that. If I, yes. It is not like that. I have maintained the gate pulse only during this instant, right? And I am expecting that during
Yes,
the
yes.
next supply cycle, SCR should automatically turn on. No.
So, sir, by which device we are giving this signal means every positive signal means at the
We are
positive.
having that gate cathode circuit, na?
Okay. Sir,
And
means
actually that
at perfectly at the positive time we are giving the signal. So that I'm asking for, we are using what device, sir? Means
actually the thing we are doing is we are not using the any device. Actually, the thing is what we are doing. We are putting a switch there in the gate cathode circuit. And actually, in order to differentiate your gate cathode circuit and the anode cathode circuit, we are using one pulse transformer.
okay.
Okay, that you will understand when we discuss the pulse transformer. Actually, here to not discuss the gate cathode characteristic of the SCR, na. So that's
sir.
why.
So means we are
after that
discussing only for one cycle only.
Yeah, this discussion is only for one cycle.
Okay, sir.
Right?
And sir, please explain shortly, sir, the TC and TQ means the device circuit
Okay.
time.
Okay. TQ means what? It is a device turn off time. Means how much time is required for the device to turn off. That will be given by your dynamic characteristics of the SCR we discussed.
Okay, sir.
And in that case, we mentioned one term, that is a TQ, na, which is equal to TRR plus TGR.
Yes, sir.
So that value TRR plus TGR, it depends on that device, okay, construction.
Okay.
And the device manufacturer will give the value of TQ.
Yes, sir.
But the
Means
design
for
engineer,
different TQ, sir, we have different construction, manufacturing construction.
yes. For different constructions, for different levels of doping, for different levels of your widths of the layers, na, you are having the different TQ.
Okay, sir.
Right? Suppose manufacturer has manufactured one device. Suppose this is a SCR. For this particular SCR, the manufacturer will give the TQ value. And the design engineer's role is like he need to select the value of inductor and capacitor, that is the commutating elements, na, such that TC should be greater than or equal to TQ.
Okay.
Right? TC is a circuit turn off time. That value will be decided by the design engineer. But whereas TQ is the value that will be given by the manufacturer, and it depends on the manufacturing of the device. Right?
Okay.
Construction
And
of the
sir,
device.
TC depend on inductor and capacitance of the circuit.
Yeah. TC depends on your commutation circuit.
Okay.
In the commutation circuit, we are using inductor and capacitor, na?
Sir.
Right? Same.
Okay.
And
sir,
good evening, sir.
Also
Hello.
this voltage communication and other communication, we are using practically this type of communication, sir.
Yes, we are using these type of commutations, voltage and current commutation.
So the voltage commutation circuit is very complex, so we are using that means for commutating.
Yes, we are using that for even your DC to DC converter, na, and your inverters.
Okay,
Right?
sir. Thank you.
Yeah. It is complicated, but that plays a very crucial role, na, because if your SCR fails to turn off, definitely your circuit output will change, na.
Sir.
So that's why we need to put that commutation circuitry there.
Okay.
Okay. Yes.
Hello, sir.
Yes, please.
Sir, in mode 3.
Mode 3.
Yes, sir. Where the capacitor is discharging minus Vs at the load, no, sir. Sir, when it charges to plus Vc, could you explain that? I understand through that mathematical ramp signal,
Okay.
but conceptually I understand that how it charges to plus Vs.
Okay, it means how capacitor charges to the plus Vs.
I understand
mode
through
3
ramp
you
signal,
want.
sir. In mode 3.
Mode 3, na. So actually the thing is what is happening. Suppose this capacitor at the start of mode 3, the polarity was like plus here, minus here, na?
Yes, sir.
So when capacitor discharges through auxiliary thyristor, it is like a capacitor. Capacitor discharges means what happens? From one
lo-
plate to right capacitor from that plate. Okay. Suppose upper plate positive charges are there and lower plate negative charges are there. So when capacitor discharges means what? Those capacitor charges. Okay. Those charges will be moving from that plate to the other circuit, external circuit. Okay.
Yes, sir.
So it will be like these means capacitor go on discharging here and again charges to the reverse polarity. Means if initially the voltage is like plus 5 volt, then at the end of mode 3 that will be minus 5 volt.
Sir, it can be said that the capacitor is
Huh.
discharging in the inductance and again it's charged through the inductance.
Capacitor charges through the inductance and discharge. Yeah, you can see.
But
Right.
that freewheeling diode is taking that the charges, no, sir, from that inductor.
No, freewheeling diode is in the off state, na. When this TA turns, when this TA is in on state, at that time your freewheeling diode will be in the off state.
Yes, sir. But
Huh.
capacitor is discharging through the L. At that time, the inductor will be charges. At that instant, the capacitor is discharged. At that time,
Huh.
the freewheeling diode is on through the inductor. Then how can we charges to the VS at the capacitor? I did not understand.
When capacitor discharges, you are saying when capacitor discharges, freewheeling diode will be
Off.
state, correct?
When after that capacitor discharges to the inductor will start to the discharges. At that time, freewheeling diode is on.
Okay. Okay. Means
It-
your doubt is
it-
when capacitor discharges, at that time inductor stores energy.
Yes, sir.
Okay, and you mean to say when means during from this point to this point, from here to here. Okay, that is let us consider for VC from this point to this point. Okay, so you are saying that it is like capacitor is discharging and inductor is storing the charges.
Yes, sir.
And after this, how this means why the inductor is not releasing the energy through this part?
Yes, sir.
No, actually the thing is here, if you check, we are having the capacitor and at this side supply voltage is also there, na?
Yes, sir.
If in the case, if suppose we are having the circuit like we are having only capacitor that has charged to some voltage, okay, and suppose this supply voltage is not there in the picture, right?
Okay.
Then whatever you are saying, okay, that will be true. But here we are having the supply voltage also, na?
Yes, sir.
So due to
Higher
that-
polarity.
Yes. That's why our capacitor will again charges,
Oh, okay. I understand, sir.
right?
Sir,
If
what is the
Huh.
sir? What is the use of the E in the place of the load terminal?
what is the use of
What time we use the E? The battery is there, no, sir. EMF is in.
yes? Okay.
Right. What time
No,
we use
actually
that?
the thing is that your RLE load means your motor load, DC motor.
Okay.
And in that case, whatever the back EMF is there, na,
Yes, sir.
that back EMF will be indicated with this E. Actually, the thing is, you will understand it when we discuss the rectifier circuitry. In the RLE, we are having the two types. One is the continuous and second one is discontinuous. If the load is, if we say the highly inductive, na,
Yes,
then
sir.
it is like the effect of E will not be observed in the operation of the circuit.
Okay,
But
sir.
if the suppose if we reduce the value of this inductor by some amount, okay, then
Okay.
it is like the E value will be observed in the output voltage.
Okay, sir.
Right? You will understand
Yes.
it in the rectifier circuitry.
Okay. Sir, if they ask the
Ah.
question about the find the output voltage V0, it through which formula we can find that V0, sir? How you can
That
find
I will
V0?
tell you during DC to DC converter because this is a commutation. So
Yes,
that's
sir.
why yes, but we can find the V0 means V0 average we need to find here.
Okay. Sir, the main thyristor will be
V0
overloaded, no,
average
sir.
means yes.
The main thyristor T1 is overloaded when we pass the overcurrent with the high polarity.
Will you please repeat it?
The main thyristor will maybe the over voltages at the time that we can discharges to the VS, no, sir. It may be damages. Is there any chances in that?
When thyristor T1 damages, then
I am saying that in practical application, can we say that the T1 is overrated because of the negative? There is a discharging current through the T1, sir.
Okay, means you are saying the current flowing through the T1 is greater than that of the rated current.
Yes, sir.
Okay, then what happens?
Overrated maybe occur.
No, no, actually
may
the
damage.
thing is, no, we need to select the value of T1 by considering its maximum current, na? How
Yes,
much
sir.
maximum current is flowing. So if I know the maximum current value, right? Then accordingly I can select the value of the T1. And important thing is, while selecting the particular device for any application or any circuit, suppose if my circuit is giving the peak value of current flowing through this switch is like let us consider as 100 ampere, then then it is not like that I will be selecting the value of thyristor which is having a maximum current rating of 100 ampere. No, I will select somewhat slight higher current rating thyristor. Okay,
Okay, sir.
in order to avoid that whatever you are saying, the damage and that case. Okay.
Okay, sir. Sir, I sent that third question. Can you draw that? Most of students are confused in that question, sir.
Which one?
I said that one BJT and diode is there, no, sir.
Just
There is a composite circuit switch.
composite switch. Just a minute.
I sent in WhatsApp.
Yes, OA na.
हाँ वही जो आप वापस सेंड करा था ना WhatsApp.
Yes, this one.
No sir, I sent other question same as that.
Okay.
There is a diode
Which
in the
question you
series
are
with.
saying?
There
Which
is
question you are saying?
not in that question, sir. It's other than that question.
Yeah. Tell me, what do you want?
And the BJT, draw one BJT at the emitter terminal. Use the one
Just a minute.
emitter terminal. Use the reverse polarity of diode. Emitter terminal.
Here.
Here emitter terminal.
Okay.
Downward,
Here.
sir. Reverse polarity of diode. At
This
what
like
position
this?
with the SOA?
Like this, na?
Yes, sir.
Okay. So this is like your A and B, na?
Yes, sir.
So your SOA will be like this. Whether our switch, let me write it as a V, okay? And this is a current I, okay? So
Okay.
you can check when BJT is in an off state, definitely the forward voltage will be blocked, right?
Yes, sir.
Whether the forward current will flow? No, forward current will not flow.
Yes,
Right?
sir.
Next, during the reverse bias, our BJT is not blocking the voltage, right? BJT will not block the voltage, and the reverse current also will not flow. So that will be like only forward current will be flowing. The forward voltage will be blocked.
Sir, due to composite switch, it can be flow that the negative current.
Due to the
Composite diode is there, no, sir, in the series of.
no, but whether your BJT allows the negative current?
No. If in parallel,
No,
it will.
for BJT, we are having this type of for BJT alone, if you check, we are having this type of yes, voltage and current. It is a unidirectional and unipolar, na?
Yes, sir.
This is for BJT alone, right? So BJT is not allowing the reverse current. BJT will not block that reverse voltage, right?
Okay, sir.
It will be like this only.
Okay, sir.
Correct?
Thank you, sir.
Why
Yes,
the
sir.
BJT not blocking the reverse voltage? That you will understand while discussing that BJT. Okay.
Okay,
Because
sir.
particularly for power applications, right? For high voltages, our BJT will not block that reverse voltage. That is the thing. Okay.
Okay, sir.
Good evening, sir.
Yeah. Good evening.
Peak current through thyristor 1 expression. Show me one, sir.
Just a minute. Peak current through
T1.
Okay. Voltage commutation. Peak current through thyristor T1. Yes, here it is.
Expression you have derived, sir.
Yes.
Before the problem slide. Peak current
Okay.
expression, sir. I need to write down once.
Yes.
Before
I0 plus
before-
IC peak.
No, sir. Not in problem. In expression before slide.
Before problem slide, na?
Before slide, sir.
Yes. This one. And you want this expression, right?
Sir, I need to write down.
This one, na?
Sir.
Okay, okay,
Scroll down, sir, little bit.
okay. Okay.
Okay, sir. And
hello, sir.
in diagram, sir, during mode 3, show me one, sir.
During mode 3. Okay.
During mode 3, you have IC is equal to minus I0.
IC is equal to minus I0. Yes.
Circuit you have drawn, sir. Mode 3 circuit.
Mode 3 circuit you want. Okay, mode 3. Yes, this one.
Yes. 1 minute, sir. I need to snapshot.
Okay. Okay, okay.
Okay, sir. Sir, please open the characteristic diagram one, sir. Voltage commutation graph.
Graph.
Sir.
Yes.
Sir, in mode 4, output voltage is 0, no, sir.
Mode 4 output voltage is 0. Okay.
So output power is also 0 in this state, sir.
Output power is also 0, right?
So there is no current.
No,
power
it is
output
not
in-
like that. Actually, the thing is, suppose if this is the motor,
Yes, sir.
okay. So voltage across motor is 0, but whether the current is flowing through the motor, yes, because your motor inductor is circulating the current, na?
Yes, sir.
Don't
Sir,
consider it as a passive load. Consider it as like a motor load, RLE load.
Even
And
though voltage
again,
is
you can
0,
check. Yes, yes, please.
even though voltage is 0, the current flowing through the output devices, sir.
Yes, yes, current is flowing. It is not like that current is, you can check na, V0 0, I0 is, V0 is 0 volt, I0 is non-zero, na?
Sir.
Current is flowing there, right?
Power output is not 0, sir.
Power output will be 0 only because it is a V0 into I0.
Acha, okay, sir. Sir,
Right?
in this diagram, auxiliary thyristor will only operate it for mode 3, sir.
Yeah, auxiliary thyristor will be operated during the mode 3. You can check TA is on here, right? And here it is an off state.
So our main thyristor will work for only mode 1 and mode 2.
Yeah, yeah, main thyristor will, yes, will be in the on state only for mode 1, mode 2.
Sir, this is a disadvantage, na, sir. We want to turn off one thyristor. We want to use another thyristor, sir.
No, no, but we don't have other option. Na?
Alternative.
Yes. In the current commutation also you can check. We need to add we need to add one more thyristor. Means in order to turn off the main thyristor, we need to go for the auxiliary thyristor only.
Sir, in this diagram, I understand that the only capacitor will control the T1 and auxiliary thyristor also, sir.
Yes, yes.
Sir,
Correct.
this is the key
Capacitor
flavor.
plays a very important role. Capacitor as well as your inductor also. These two elements are playing very important role.
Yeah, and one more doubt is there's switches are RC switch.
Yes, RC. Yeah, RC
We
is
need
the
to- We need to switch on up for every mode 1 cycle, sir, continuously repeated.
no, at the start only.
Only.
At the start of the start.
Sir, after mode.
Suppose
mode
initially suppose circuit is at the rest position.
Yes, sir.
At the start, in order to charge the capacitor, we are using this switch. You can check once mode 4 completes, na.
Yes, sir.
After that, again, if I apply the gate signal,
Okay.
then before that instant, you can check what is the voltage across the capacitor. It is a VS already, na.
Yes, sir. It is holding.
So no need not to again switch on this. Right?
Okay, okay, sir. Okay, sir.
Okay. Yeah.
Thank you very
Hello,
much.
sir. Can you
Okay.
open
good evening, sir.
two transistor
Yeah, good
analogy?
evening.
Sir, in this voltage commutation,
Ah.
can you explain once that why the voltage commutation, sir? In that the capacitor voltage current through the capacitor is opposite to IT1, then the T1 current is suddenly going to 0, no, sir?
Just a minute. Will you please repeat?
Capacitor current, sir. The IC is opposite to
IC.
IT1.
IC opposes to
IT1.
IC opposes to IT1.
In that
During
mode
the
one,
mode 3. During the mode 3.
yes, sir. Yes, sir.
Okay, okay, yes,
T1 going to off, sir.
correct.
Yes, sir. In that, that is okay, sir. But why that voltage commutation? Can you explain once, sir?
Why this is known as a voltage commutation?
You already explained, sir. But can you once
Okay,
explain?
okay. The thing is actually, you can check during mode 2, thyristor T1 is in on state.
Yes, sir.
Auxiliary thyristor was not on. Okay. As soon as I apply the gate signal to the auxiliary thyristor, it is like this capacitor voltage will appear as a reverse voltage for thyristor T1. Na?
Yes, sir.
So capacitor is actually turning off, sorry, thyristor T1 is actually turning off due to the reverse voltage. That's why it is a voltage commutation.
Due to
Okay.
reverse voltage.
Due to the reverse, due to the high reverse voltage, capacitor is turning off.
Okay, sir.
That's why it is a voltage commutation.
Sir,
But
one.
whereas if you check tomorrow we'll discuss the current commutation. In that you will understand the thyristor will turn off. First of all, it is like a current flowing to thyristor T1 becomes 0. And after that the reverse voltage will be maintained. But here the current flowing to thyristor, definitely in order to turn off the thyristor, very first requirement is current flowing to thyristor should be less than the holding current value, right?
Yes, sir.
But how this current flowing through thyristor T1 is becoming less than the thyristor holding current, becoming less than the holding current? This is due to the reverse voltage, na?
Okay, sir.
That's why it is a voltage commutation, right?
Sir, the holding current is less than or equal to anode current, only less than, sir.
For turn off,
Yes, sir.
for turn off it is less than, only less than or equal to nahi, only less than.
For turn on is less than or equal to, sir.
In order to maintain it is on state, it should be greater than or equal to.
Greater than the equal to, sir.
Greater than or equal to means minimum value should be equal to holding current. But in order to turn off, that anode current should be less than holding current, right?
Sir, one more doubt, sir.
Yes.
Sir,
Yes,
what is
please.
the main purpose of the true transistor energy, sir?
What is the main purpose of two transistor analogy?
Sir,
Actually, if you check the
advantage, sir.
yes, if you check the output expression, na,
Yes, sir.
that is the expression for the anode current, which is equal to alpha 2 into Ig plus ICBO1 plus ICBOT upon 1 minus in bracket alpha 1 plus alpha 2, right? So
Yes,
what
sir.
that indicates, actually it gives the mathematical proof for how the current flowing through the SCR increases from leakage current to the high value by circulation of very small gate current. Before this also we discussed the gate triggering, na?
Yes, sir.
But that was your theoretical approach. And the two transistor analogy will give you the mathematical approach or the mathematical proof, right?
Okay. Sir, one more last doubt, sir.
Yes, please.
Sir, there is any difference that between normal diode and freewheeling diodes?
Any difference between normal diode and?
Freewheeling diodes.
Generally, you won't find any difference here. But generally, the freewheeling diode purpose is to allow the releasing current of the inductor. Means when inductor releases the energy, na, at
Yes.
that time we need to, that freewheeling diode should be in the conduction mode.
Sir, the freewheeling diode will store the energy, sir. Is there
No,
any?
it will not store. It will not store. Means store the energy means how? No, whether the diode is storing the energy.
No.
Same. Diode is a passive element. Our switch will not store the energy at all. But switches are having the stored charges. We have discussed the minority charge carrier devices.
Yes, sir.
And due to those stored charges, they are taking some time to turn off.
Okay, sir.
The same operation will be there in a freewheeling diode, but freewheeling diode will be already getting, freewheeling diode will be in the on state for very small time interval. During mode 4 only freewheeling diode will be in the conduction mode.
Yes,
So
sir.
after mode 4 again the freewheeling diode will be getting 3 modes, na?
Yes,
So
sir.
that's why within those 3 modes the freewheeling diode will be will be getting the sufficient time to turn off. So that's why no issue with the freewheeling diode, right?
Okay, sir.
Hello, sir.
Good
Sir.
evening, sir.
Yes,
Hello,
yes.
sir.
Good evening.
Hello, sir.
Okay.
One
Sir,
by one,
during
one
mode
by
3.
one. Yes, yes.
Okay, sir. Sir, during mode 3, sir, we are saying that the T1 is turning off due to the high current flowing through it, right, sir?
Yes.
Sir, but supply voltage will also circulate current, sir, through it, no, sir? Sir, how we
But-
decide in which
Yes, yes.
direction the current will flow?
No, I will tell you na. You can check during mode 3 what is happening. This is like our thyristor we are having. Okay.
Yes, sir.
Here it is a capacitor. Here it is auxiliary thyristor we turned on na.
Yes, sir.
Main thyristor is also in the on state.
Yes, sir.
This is a capacitor which is charged to the minus here plus here. This is a Vs na. As soon as your auxiliary thyristor turns on, this capacitor will try to discharge like this.
Yes, sir.
Before this auxiliary thyristor, that is before the start of the mode 3, current flowing through the thyristor T1 was I0 na. You can check, actually current flowing through the thyristor T1 was only I0 before mode 3.
Right, sir.
And if you check at the start of mode 3, when auxiliary thyristor turns on, how much, yes, what is the magnitude of this current? Can you imagine? We're having the supply voltage, it is in the range of 200-300 volts, and across it we don't have any element to control that current. So
Yes, sir.
very high current will flow na. So
Short circuit
definitely
current
that
will flow.
discharging current of the capacitor will be greater than that of your I0.
Okay,
So
okay, sir.
that's why. And but important thing is, due to that high reverse current, our main thyristor will not get damaged, because you can check, suppose here current is flowing 100, let us consider this as a 100 ampere. Suppose it is a 100 ampere. Okay. And reverse current which is flowing, let us consider it as a 800 ampere. So resultant current will be 700 ampere na,
Right, sir. Yes, sir.
in opposition. But whether that current is flowing for very or the finite time, no na. For very short interval that current is flowing. So that's why this current will not damage our thyristor. Okay.
Okay, okay, sir.
Okay.
Thank you, sir.
Good evening, sir.
Good evening.
Sir, in load commutation,
Okay.
so in that you said that after T is equal to pi by omega naught value,
Okay.
TC value will be infinite.
Yes, yes. Series,
So-
in series.
So SCR will never get turned off completely. Commutation
SCR
will
will
not be
not-
complete.
Please repeat.
So TC is equal to infinite. So commutation is not done complete. No, SCR will not turn off.
No. TC is infinite. The meaning is definitely our TC will be greater than TQ na.
Yes, sir.
So if
Okay.
TC infinite means what? Definitely we can say that our circuit turn off time is 100%. It is a greater than that of your TQ. So our SCR will successfully commutate na.
Okay. So TC
What-
is exactly
Yes, yes.
what, sir? TC is the value.
TC is a circuit turn off time. TC means what? Why the TC is required? In order to maintain the reverse voltage across the thyristor.
Okay.
Why the reverse voltage is required to maintain across thyristor? In order to remove the added charge carriers na?
Yes, sir.
Actually, the TC is required to remove the added charge carriers specifically.
Okay. So it has no relation to turn off and turn on of SCR.
No, it has a relation with the turn off time of the SCR na. Suppose if my TC is less than TQ. TQ is
Yes.
a device turn off time.
Yes, sir.
TC is a circuit turn off time. Suppose if I
Acha.
select the value of in this circuit, we cannot say. Suppose in the voltage commutation circuit, if I select the value of L and C such that my TC is less than TQ.
Hmm.
If TC is less than TQ, our SCR will not turn off successfully. And if I apply the gate signal again, na, if I again apply the forward voltage, na,
Hmm.
our SCR will again turn on without the applying the gate signal even. So that is the failure, na.
Yes, sir. So if TQ is the time required to turn off SCR and TC is the time required to remove the additional charge cables.
No, we cannot. You cannot say directly like that. Okay,
Okay.
because
So-
TQ, according to the manufacturer,
Hmm.
to get for the removal of the added charge carriers. Okay,
Hmm.
the time required is a TQ. means manufacturer says that you need to maintain the device in the reverse bias mode, okay, for minimum time of TQ. This is the manufacturer saying, okay.
Okay.
Now the design engineer's role is whatever the manufacturer has said, okay. So accordingly, the design engineer's role is like to select the value of L and C so that TC should be greater than or equal to TQ. That's it. Because if you in both the cases, you are having the removal of the stored charges TQ and TC. But if I keep the value of TC is equal to TQ, then also my device will turn off, no doubt. If I keep TC greater than TQ, then also my device will turn off, no doubt. But if I keep TC less than TQ, our device will not turn off, na?
So, sir, what is the difference then? TC is exactly circuit turn off time. So
Yes.
And TQ is for the turn off of SCR, for turning off SCR TQ value. But I'm not able to understand this difference between TQ and TC.
Okay, just a minute, let me. First thing is the dynamic characteristics of SCR during turn off. This is the
Yes,
thing. So there we have seen that during the dynamic characteristics of SCR, we're having the current decreasing, it reaches the zero value and again it goes into the negative. Yes or no?
Yes, sir.
What that negative indicates? Why the current has gone to the negative? Because of the stored added charge carriers.
Added charge.
Right? Yes, charge carriers. So important thing is, in order to turn off that SCR, we need to remove the charge carriers.
Yes, sir.
So according to the manufacturer says that if you want to turn off the SCR successfully,
Yes.
you need to maintain the reverse voltage across the SCR for minimum time of TQ. For minimum time of TQ.
Yes, sir.
So now if I want to use that SCR in my circuit, then what I need to do in order to turn off that SCR? Yes, we need to use the commutation circuitry. And in that commutation circuitry, I need to select the elements. I need to put the components in such a way that the TC, my TC should be greater than or equal to TQ.
So that all the additional charge carriers are removed.
Yes, those will be getting removed.
Okay. And then SCR will turn.
Then SCR will turn off. Because the thing is, it is not like that after one cycle we are stopping now.
So,
In
sir,
real life, what we are
Yes.
doing, suppose if you consider the inverter circuitry, and
Yes.
suppose inverter circuitry is having the output frequency of 100 kilohertz, then you
Yes.
can imagine in 1 second we require 100k cycles, na?
Yes, sir.
So 100k cycles means after one cycle, one output, our SCR should successfully turn off, and again for getting the next output cycle, the SCR should again turn on, na?
Yes, sir. So the minimum time required to turn off the SCR is TQ value. Minimum time.
Yes, it is a TQ. It is specifically
Yeah,
TQ only.
minimum time, and it TC can be greater than TQ.
Can be greater than or equal to.
Equal to. Okay, understood. Thank you.
Okay. Yes.
Sir,
Ah,
voltage
yes.
commutation.
Yes.
In the mode 1, with the first circuit, you in the second circuit, the voltage VS is additionally connected, sir. Connected to capacitance, sir.
During the mode 1,
yes, sir. The capacitance is additionally connected to connected with VS, sir. Why the equivalent in the equivalent circuit? Why the VS is connected, sir?
here you are saying
Down, sir.
mode 1, na?
Mode 1 now down, sir. Down, somewhat down. Next circuit. Yeah, here, sir.
This one here.
Yeah, sir.
Okay. Actually, the thing is what I have done. We are having this circuit actually. This is the circuit we are having actual. Okay.
Yes, sir.
If I apply KVL to this circuit, then we will be getting plus VS, okay, or plus VC minus L DIC by dt is equal to 0, okay.
Sir.
But here if I want to suppose, let me write here VC plus L into DIC by dt, na?
Yes, sir.
Okay.
Minus.
So it is a 1 by C integration of IC dt will be there. Okay. VC means what? 1 by C integration of IC dt actually. Okay. Okay. So VC is actually 1 by C integration of IC into dt, right? Plus this thing. But in this case, if I want to apply the Laplace, that I need to use in the Laplace transform, we are having that property, non-zero initial condition.
Okay, sir.
That thing I need to use here. So in order to avoid this, actually that is actually somewhat confusing. So that's why what I did, I have added this initial voltage of the capacitor here.
Okay, sir.
And I have considered the passive capacitor here. Because the same thing we are having, we are having the initial voltage across capacitor, and at the same time we are having capacitor passive also. These two things I have separated here. And after that I have applied KVL, but you can check in this KVL equation after for taking the Laplace transform. Okay. Here I need not to use the Laplace transform property with a non-zero initial condition. That property I need not to use. I can use the zero initial condition property here because the initial voltage I have already considered,
Sir.
right? So either you can simplify by this way, or by this way you will be getting the same answer, right?
Okay, sir.
Okay.
Hello, sir.
Yes, please.
Sir, how to find the circuit turn-off time? Will you please explain it once?
Just a minute. Okay. Circuit turn-off time. Keep it in mind. Two things only. First thing is we need to find the instant at which current flowing through thyristor becomes zero.
Yes.
Because that is the first requirement now in order to commute the thyristor.
Yes.
So here you can check IT1 is the current flowing through thyristor T1. That current is becoming zero at this instant now.
Yes.
Now you can check at this instant current is becoming zero. After that, what is the second requirement for commutation? We need to maintain the reverse voltage.
Yes, sir.
So now you can check from this point. Yes, we need to check for VT1, that is voltage across thyristor T1. So
Yes.
this point is nothing but this point on VT1 here. And here you
Yes.
can check from this point to this point. We are having the reverse voltage now.
Yes.
So that's why this is a TC. TC is nothing but the time corresponding to which the reverse voltage appears across the SCR. But that time will start only from thyristor current becomes zero. Are you getting the point?
Yes, sir. Sir, but how to make the formula for circuit turn-off time?
Okay. Then for that, what I did during TC means during this interval, during
Yes,
this
sir.
interval, you can check what is the IC value. IC is I0.
Yes.
And what is VC? VC is this type of waveform.
Yes, sir.
So what I have done during TC, I have written IC. We know IC means capacitor current is equal to what general expression? C into dVC by dt.
Yes, sir.
So now during TC, can I replace that IC with I0?
Yes, sir.
Next, during TC, can we write dVC means what? Change in the capacitor voltage. Change
Yes,
in the
sir.
capacitor voltage means this is a capacitor voltage which is changing from minus Vs to zero.
Yes, sir.
So change in capacitor voltage is like final value minus initial value.
Yes,
That
sir.
is a zero minus of minus Vs. So it is a Vs only.
Yes, sir.
And what is the change in time? That is a TC. So I have written IC is equal to C into dVC by dt. Yes, here it is. IC is equal to C dVC by dt. And what is IC during TC? It is I0, na?
Yes, sir.
What C as it is, and dVC is 0 minus of minus Vs, and dt is TC, right? And
Yes,
accordingly, we have written TC value expression.
Sir, is there any generalized formula for
No. There is no generalized formula. You can check in current commutation. You will get another way. Okay.
different types of circuit? We get different circuit.
Yes. Different types of circuits will be getting different.
Okay, sir. Thank you.
Okay. The only thing is we need to check for IC and VC actually. Okay.
Yes, sir.
From
So
that
along,
you will get an idea.
along with VT and IT, we have to check IC and VC as well.
Yes. We need to check instead of VT and IT. We need to check actually VC and IC.
Okay, sir.
Right. Okay. Yes. Next.
Good evening, sir.
Yeah. Good evening.
Sir, I have small doubt about modes of operation. It depends on only L and C elements, sir.
modes of operation means commutation circuit modes of operation.
Yeah, yes, sir.
No, actually these modes of operation, these modes, mode 1, mode 2, mode 3, mode 4, okay.
Yes, sir.
We have only divided it in order to understand the circuit operation. That's it.
Okay.
Okay, there is no thumb rule like there should be the 4 modes and those things. No, right? In order
Okay.
to understand it, we have divided because we have the steps like now. First of all, thyristor T1 turns on, then it is like capacitor discharges and again charges to the reverse polarity. Next, we discuss the mode 2 means we have not applied the gate signal to auxiliary thyristor yet. Then what will happen? Right? Like this, we have divided circuit operation.
Okay, sir.
Okay.
Sir. Okay, sir. Sir, tell me some shortcut about how can you remember this circuits, output waveforms.
Okay. Shortcut is not there. The only thing is you need to draw it. You need to practice it. Okay. Because hardly we are having the load commutation is very easy to understand, right?
Yes, sir.
The only thing is load commutation and the current commutation. These two circuits you need to practice, right? And you will understand. The thing is, once you understand the circuit, right? Once you know the circuit, and if you understand the circuit operation, definitely you can draw the waveform.
Okay,
We cannot mug all the waveforms and all the circuits. No. The thing is, you need to first of all memorize the circuit diagram. Once you memorize the circuit diagram, after that you can understand the circuit operation, and from circuit operation you can draw the waveforms. Okay.
Okay, sir.
Because in power electronics we are having the n number of circuit diagrams, right?
Yes, sir.
Yeah. But if you go on practicing, you will understand, and those are very interesting actually circuits. Okay.
Okay, sir. Thank you, sir.
Yes, sir.
Hello, good evening, sir.
Good evening.
In two transistor analogy one can you open after current equation.
Okay, two transistor analogy of SCR. Yes.
After the equation, you have written Ig equal to 0.
Yes. This one.
After that.
Here
yes,
it is.
So in here you didn't write 1 minus alpha 1 alpha 2 in the above. Ig equal to 0 SCR of. Ia equal to ICBO1 plus ICBO2 divide. You didn't write divided by, so
Here you are saying?
yes, sir.
No. Here I have explained.
Above one, sir. Above to initiate turn off process.
To initiate here, na?
In the box you have written Ia equal to ICBO1 plus.
Means I have not written 1 minus alpha 1 plus alpha 2. You are saying.
Yes, sir.
The thing is, if Ig is 0,
okay, sir.
You can check this expression. If Ig 0 means alpha to Ig will be 0.
Yes,
right?
Sir. Alpha 2. Why, sir? Alpha 2 0.
If Ig 0, then alpha 2 into Ig, that product 0,
yes,
na?
That product is 0, sir. Okay. Yes, sir.
Just a minute. That product is 0. Now you can check in the SCR. We are having the SCR. In that gate current is not circulated. Okay.
Yes,
then how much current will be flowing through the SCR? That is very small current, na?
Okay, sir. Yes,
so
sir.
if the very small current is flowing, no, just a minute. If the very small current is flowing through the SCR, ideally speaking, that current should be 0. But practically some small current will be flowing, right?
Right, yes, sir.
So therefore, can we say that Ia will be very small? Ik will be very small?
Yes.
Ik means what? Ia plus Ig, na?
Yes, sir.
Ig 0 we are having, and the actually gate current is not circulated means this transistor is in off state. This transistor is also in off state.
Yes.
So that's why Ia is very small.
Yes, sir.
Ia plus this 0, Ig is 0, na? So Ia plus this 0 is nothing but Ik. So Ia is equal to Ik. This is also very small. So we are having IE1. Ia means IE1.
Yes, sir.
Ik is IE2.
Yes, sir.
If Ia is small, IE1 is small, Ik is small, IE2 is also small.
Yes, sir.
If IE1 and IE2 are very small, what about the alpha 1, alpha 2? Very small, na?
Very small, yes, sir.
So if these are very small, so what about the addition of these two? That will be also very small.
Yes.
So this difference 1 minus alpha 1 plus alpha 2, that difference will be nearly equal to 1, na?
Yes, sir. Yes, sir.
So if this is 1, so that's why I have not written here divided by 1, right?
So one another doubt, sir, you have said that power BJT doesn't block reverse voltage. It is an
Yes.
exception, no, sir, only for power BJT. Normally BJT
Yes, yes.
blocks
Yeah,
reverse
this is
voltage.
only for power BJT.
Yeah, sir. Okay, that's it.
Because we're dealing with the power electronics, na, power devices.
Okay. Thank you, sir.
Yes.
Sir,
Okay, okay. Yes.
sir, would you upload these notes today night or early morning, sir?
No, today night only I will upload. Don't worry about it. Okay. The thing
Okay,
is
every day?
actually when I am converting this OneNote format into the PDF, na.
Yes, sir.
Yes, I am getting some of the pages blank and or whatever the data is there, na, that will be distributed in the pages. That thing is like this. So that's why I require some time. So what I am doing currently, I am taking directly print screen here.
Yes,
and
sir.
I am copying that into the Word, and then I am keeping preparing the PDF.
Save
Right?
as PDF.
Probably I will upload it today only. Okay.
But so why, sir? I am joining early, daily 6 p.m., sir. So
Okay,
after
okay.
class, I will fulfill the notes, sir, to get the
Okay,
tomorrow.
okay. No, I will upload. I will upload. Okay.
Okay, thank you, sir. Morning also we have class, sir, so I would complete the
Okay,
notes.
yes.
Thank you, sir.
Yeah, I don't understand. I don't.
No, thank you, sir.
Okay, okay.
Hello, sir.
Yes, please.
Sir, in a load computation circuit,
Okay.
sir, why resistance value is we have taken low?
Why resistance value we have taken low?
Yes, sir.
No, actually this commutation circuit is used for either low value of REL or high value of REL.
Sir,
Right?
in this we have taken low. That's what.
If you take it as a medium type or some finite value, then this circuit will not operate at all.
Okay,
Means our main task is to turn off the SCR, na?
Yes, sir.
And if you keep the value of REL high, you will not get the response like your sinusoidal.
Yes, sir.
The thing is like that. So that's why in order to get the sinusoidal response, here your REL should be low, or the voltage across REL, na, that thing that we need to neglect. Then only then it is possible. In the control system, you might have gone through like underdamped, critical damped, and overdamped circuits, right?
Yes, sir.
Yeah. So in that you can check the for underdamped circuit, what is the type of response we are having? It is a sinusoidal, na?
Yes, sir.
So same thing. In the same way, we are interested in keeping this as a underdamped.
Okay.
That's why R value we are selecting less value here, right?
Okay, sir. And sir, the voltage twice Vs across capacitor.
Yes. Voltage twice Vs across capacitor. Then,
sir, how it means?
That we have proved, na, mathematically we have proved how much voltage we are getting, right?
No, sir. From actually from diagram, I want to ask about.
The thing is actually, suppose if the inductor is not present, here in this circuit, then your capacitor will be charged to the maximum voltage of Vs only.
Yes,
but
sir.
due to this inductor, our capacitor will be overcharged like a 2 Vs.
Okay.
Because inductor is storing the energy and after that it is releasing the energy, na?
Okay, sir. Sir,
So capacitor is doing actually supply voltage, it is energy storing. At the same time, inductor's energy also capacitor is utilizing for the charging. That's what is the 2 Vs we are getting. Yes.
Sir, whether it's a exact value that is twice Vs or somewhat less or more.
No, that will be exact twice Vs you will be getting.
Sir, inductor value could be means a change according to that.
No, then we need to select the, if you select the value of L and C different, then it will be a different value you will be getting. Because our main task is to select the value of this L and C such that this RLC circuit will be like a underdamped type behavior.
Okay.
Then and only then it is possible.
Okay, sir.
Right? Okay.
Yes. Thank you, sir.
Yeah. Next.
Hello, sir.
Yes, please.
Sir, in today's first question, which we discussed,
Just a minute. Let me open
the charge recovery.
Yes.
Sir, actually turn off is initiated from the starting itself, na, sir. So when why we are not considering the positive portion of this IA above that I mean, before the 4 microsecond, that part don't we consider, sir?
Okay. Because reverse recovery charge is there, na? What this reverse indicates? This current waveform is like this, negative. This is due to your stored charges, na?
Sir.
And stored charges are, yes, we are removing only during from this point to this point. So that's why we need to consider only
So
this
then
much.
before that time, sir?
Before this, no. Before this, we are not dealing with your reverse recovery charges or your stored charges. Are you getting the point? It is like suppose we are having a thyristor, and that thyristor is carrying a current of 50 ampere, 50 ampere. Okay. If I want to turn off that thyristor, then what I will do? Suppose I have maintained some reverse voltage. Okay. Then what is happening due to that reverse voltage? Okay. Our thyristor current first of all go on decreasing. Whether it will directly change from plus 50 to the negative value? No. It will decrease, na? So here decreasing means what? It indicates your current is forward only. It is not a reverse current. So actually your removal of the charges is taking place only during this triangle, right? That is during the negative values of the current, right?
Sir. Sir, but for power loss during, I mean, due to turn off, at that time, won't we consider this part?
Which part? This one?
Yes, sir.
No. For power loss during the turn off, yeah, then we can say like that. Okay, then we can consider.
Okay, sir.
Right. But currently, what is happening here? We are having the voltage 0, na?
0 voltage.
So that's why indirectly that product will be 0. Okay.
Sir. Okay, sir. Thank you, sir.
Yes. Next.
Hello, sir.
Hello, sir.
Yes. Yes, please.
Sir, what is difference between domestic
Mukul,
switches
I
and
think,
electronic switches?
before this also you attended sessions.
Yes, sir. Yes, sir. I have
means,
attended. From day one, I have.
Yes or no?
Yes, sir. Yes, sir. From day one, I have
That's
attended.
why I
always.
thought ki Mukul Jagtap, the same name was. Okay. Yeah. Please ask.
Yes. Sir, what is the difference between domestic switches and electronic switches?
What is the difference between?
Domestic switches means whatever we use in our houses, and electronic switches means whatever we studied now,
switches
BJT,
means
MOSFETs
here.
and all.
Domestic switches means here we are having the mechanical switches you are saying.
Yes, sir. Yes, sir.
Okay.
Means whatever there in a house, switchboards are there, on-off switches, and these switches. BJT,
will you
MOSFETs,
please
and SCR.
speak somewhat louder? Will you please speak somewhat louder?
Sir, whatever we are using in our house, switches on switchboards, whatever there
Yeah,
are.
those are the
there.
mechanical switches. Yes.
Okay. Okay. And
means you want the difference
what we are
between those
studied right
mechanical
now.
switches. This means you want the difference
yes, sir,
between
yes,
these
sir.
mechanical switches and our electronic switches, na?
Yes, sir. Yes, sir. Yes, sir. Those are.
Okay. Mechanical switches means simply it is like if you check inside the switch, the circuit will be like if you turn on, then indirectly there it is a short circuit inside it. And if you turn off the switch, then it will be like an open circuit, right? So same thing is here in the same logic we are using here in the electronic switch, but the thing is there we are manually operating, and here in the electronic switch, right, we are operating it with a circuitry, additional circuitry. Whether I am manually controlling the gate current, no, na. We need to design the circuitry in such a way that
automatically.
Yes, and here important thing is in the household switches, whatever we are using, those are having comparatively very less switching frequency, and our electronic switching switches are having requires very high switching frequency, na?
Yes, sir. Yes.
Yes. So the basic idea is we have taken only from these mechanical switches only, okay, but the total operation is totally different, right?
Okay. And sir, one more, sir. Sir, whatever we use in HVDC wall, mercury arc rectifiers,
Okay.
and solid state devices, means what is difference in between that? Means what is mercury arc rectifier and whatever we are using right now, solid state devices like BJT, MOSFETs, and all those things.
Okay. Means actually those mercury arc rectifiers and those things were like outdated things nowadays. You can check, you can
Okay.
compare the two if you, then here we are having somewhat advanced switches. And due to that, our switches are
Okay.
having a very less power consumption. So overall, our
Okay,
altogether efficiency of the system, okay, has improved to a great extent. At the same time, if you check our electronic circuitry, and if you compare the whatever the previously we were using, the overall the size of the
Okay.
converter also, if you check, the size has also greatly reduced.
Yes, yes.
Okay. So
Reduced,
power
yes.
electronic switches or the power electronic converters are having a very great advantages, right?
Yes, sir. Okay, sir. Thank you, sir. That's all, sir.
Yes. Yes. Next,
Hello, sir.
Nagasai. Right?
Hello, sir. Yes, sir.
Yes. Yeah.
In mode 3, in voltage commutation circuit, in mode 3 operation.
Mode 3 operation, voltage commutation circuit. Yes.
How will be auxiliary thyristor will be off, sir?
Okay. Yes. How will the auxiliary thyristor will be off? Okay. So first thing is, in order to turn off any thyristor, what is required? First thing is current flowing through it should be 0. Okay.
0.
So you
Capacitor
can
current.
check. Yes. During mode 3, if you check, and capacitor is discharging, right?
Yes, sir.
And again charges to the reverse polarity. So when capacitor charges to the reverse polarity, it is like a plus here, minus here, final voltage.
Yes, sir.
So when capacitor charges to the reverse polarity, means plus here, minus here. After that, what will happen? Our capacitor will try to discharge to the T1.
Yes,
but whether T1 is in on state? No.
Off state.
Right? Capacitor will try to discharge in opposition to that of the supply voltage, but equal and opposite forces will be there. So capacitor will not discharge.
Yes,
right? So whether capacitor is not discharging, so what about the capacitor current flowing through the capacitor? 0. Current flowing capacitor is 0. So what about your auxiliary thyristor current? 0. So here auxiliary thyristor turns off. Second thing is,
second condition.
What about the voltage? What about the voltage that is appearing across the auxiliary thyristor? You can check. Capacitor voltage is plus here, minus here, na?
Yes, sir.
This is also in off state. This is also in off state.
Both are off state now, sir.
Both are in a reverse bias mode, na?
Voltage ఎలా డివైడ్ అయ్యింది సార్? ఇప్పుడు both off state లో ఉన్నాయి కదా సార్. ఇక్కడ ప్లస్.
Yes, both these switches will be in the off state, na?
Yes, sir.
So what about the voltage across the auxiliary thyristor? Thyristor T1 voltage will be, you can check thyristor T1 voltage, it is like apply KVL to the outer loop, na?
Yes, sir.
So T1 voltage will be equal to your Vs.
Vs.
So what about the auxiliary thyristor voltage?
Okay, sir.
Right? In this way you can get.
Yes. Sir, after mode 1 operation, the theory of tank circuit is happening, sir.
After mode 1 operation, yes.
At the time of mode 1 operation also, theory of tank circuit, na, sir.
Theory of?
The capacitor in series with
inductor,
na, sir. Sir.
How
will be capacitor voltage, sir? Vc equal
after
to
mode 1 operation. Matlab during mode 1 or after mode 1?
During mode 1.
During mode 1. Okay.
Yes,
so it is like this, na? Capacitor initially charged to the plus here, minus here. Upper plate positive, lower plate negative. So when capacitor discharges through this loop, na?
Loop to discharge, sir.
Yes, through this loop capacitor is discharging. The same thing we have written here.
Yes, sir. Through
During
loop discharge.
mode
Capacitor voltage ఒకసారి ఫార్ములా రాయండి సార్ ఒకసారి దాని capacitor voltage.
Capacitor voltage is?
అంటే ఇప్పుడు అది ప్లస్ మైనస్ ప్లస్ Vs తో చార్జ్ అయింది కదా సార్.
Capacitor voltage like this, na?
డిశ్చార్జ్ అయింది కదా సార్. డిశ్చార్జ్ అయ్యేప్పుడు ఫార్ములా రాయండి.
Capacitor discharges.
Sir.
And again charges to the reverse polarity, because you can check in this loop wearing only capacitor and inductor.
Yes, sir.
Right? Now in this loop, definitely the external voltage source is not present. But you can check in this loop where only capacitor and the inductor. Out of these two elements, whether these two elements causes the power loss? No. Resistor causes the power loss. No? These two are not causing power loss. So that's why capacitor will again discharge and charges to the reverse polarity. But whereas if you check the next, whatever the interval we discussed, that is I think mode 4 interval, right?
Yes, sir. Yes.
In that resistor is there in the picture, but due to
Yes,
this
sir.
supply voltage, capacitor charges to the reverse polarity.
Today last problem.
Yes.
Sir, peak current through capacitor Vs root of C by L అన్నారు కదా, sir.
This
In
one?
mode of in yes, sir. For suppose the constant load current given, if 350 given, sir, constant load current.
Okay.
At that time capacitor peak current also 350 ayana, sir, or Vs into root C. అంటే మోడ్ 3 ఆపరేషన్ లో అంటే కెపాసిటర్ లో కరెంట్ I0 ఫ్లో అవుతుంది కదా సార్. అంటే మ్యాగ్నిట్యూడ్ కన్సిడర్ చేసుకుంటే I0 కదా సార్ ఫ్లో అవుతుంది.
Telugu I don't understand actually. Yeah.
Okay. I talk in
tell
English.
me. Yes.
During mode 3 operation, the capacitor is the capacitor current I0 na, sir.
Yes.
For suppose during last problem, the constant load current is given 350 amps. At that time capacitor peak current 350 amperes or Vs into root C by L, sir.
No. Please repeat. If in this numerical, if they would have given
constant load current is 350 amperes.
Constant load current 350 ampere. Yes.
At that time the capacitor peak current is 350 amperes or 325.27.
No. Capacitor peak current is Vs under root C by L only.
At mode 3 operation, the capacitor current flowing I0 na, sir.
Okay, Miss. You are saying in that way. Okay.
Yes, sir.
Okay. Then that will be your like peak value of that your load current.
Yes.
Right. That is true. Right?
Okay.
Good. Okay.
Thank you, sir.
Yes. Next
Sir?
one, Manjunath.
Sir, once open commutator software, sir. Voltage commutation, sir.
Voltage commutation, yes.
Sir, in this circuit, there is EMF, sir, that is from load, or we are intentionally placing that there, sir?
No, that is from load. We are not placing intentionally.
So, what is the significant? What is the meaning of that, sir?
The actual thing is, this RLE load means your motor load. For example, suppose you are having a DC motor, okay?
Yes, sir.
And in that case, that you are having the back EMF, na?
Yes, sir.
So that back EMF is nothing but this E actually. But in this case, here as we have considered the load is highly inductive, na?
Yes, sir.
So as the load is highly inductive, then the effect of E will not be observed, okay, in the circuit operation. But suppose if we reduce the value of L, from highly inductive to the only, suppose we are having RLE load, okay, if we reduce the value of L, then the effect of E will be observed. Means in the V0 waveform, you will be getting the pulse of the E. Means here now we are having the Vs and 2Vs, na? If I reduce this L value, then we'll be getting some portion for some time interval in the V0, we'll be getting E also.
Okay, sir.
Right? That you will understand in the rectifier circuit, rectifier chopper actually. Okay.
Okay.
Okay. Next, Shravan Kumar.
Sir, completed, sir. I have already asked it out.
Okay. Thank you. Yes, Sainath.
Sir, regarding
Yes,
doubt
please.
regarding classes, sir. When can we expect our offline classes, sir?
Offline.
Offline classes, sir.
We don't actually, means we are not sure because government is also not giving the permission. So as soon as they give the permission, definitely we will start the offline classes, right? And for the offline classes, it
Yes,
is
sir.
better to if you communicate the office,
Okay, sir.
right? Please. Okay. Next,
Sir, you have given Telegram number, sir.
one by one. Hello.
Sir, you have given your Telegram number, sir.
I have given my
Telegram number, sir. Telegram number.
that I am not getting actually your surrounding.
Sir, my background is clear. I am audible, sir.
Yes, please.
Sir, you are giving you have contact number, sir.
Yes.
The Telegram it was working, sir. 7387 like.
My contact number, na?
Yes, sir. Is working in
No,
Telegram.
you can contact me at any time, no problem, right?
Telegram is working, sir, for your number.
No, Telegram I am not using. Why?
I have some doubts. How can I post you, sir?
No, you are not using the WhatsApp.
Okay, sir. You have for this
You can
number.
post me or you can mail me. You can send me on WhatsApp. No problem, huh?
Sir, this number have no WhatsApp, sir.
Your number?
Sir, no, your number, sir.
No. My number have a WhatsApp now. So many students are sending me the difficulties and.
Sir, please confirm one, sir. 7387864360, sir.
Yes, same number 7387864360.
I have searched in WhatsApp, but contact not visible, sir. That's why I'm
No,
asking.
please check once, right?
Okay, sir. Okay, thank
Yeah,
you.
same number is there. Same number. Okay. Yeah. Yes. Right? ठीक है.
Hello, sir.
Yes, please.
Sir, on September 1, offline classes is going on. It's true now, sir?
Yes, from September they have announced that new batch is starting at testing, but we are not sure means whether they are really starting or not. Yeah, so better to contact with the office person directly. Okay.
Okay, sir. Ante we are classroom coaching. This coaching
you
is
are classroom coaching.
yes, sir. Offline, then continue with offline, sir.
Okay.
Okay, sir.
Just contact the office person. Okay.
Okay, sir. Thank you, sir.
Okay. Okay. Thank you. Thanks to all of you.